When you look at the night sky, you are often taught that you are a human looking out at the universe. But if we follow the chemistry to its origin, you are actually the universe looking back at itself. For 13 billion years, the cosmos existed without a single witness to its scale or complexity. It was a massive physical process operating in absolute, unobserved silence. This silence began 13.8 billion years ago. In an instant, every bit of matter and energy that would ever exist was compressed into a single, unfathomably hot point that suddenly expanded with violent intensity. This early era was thick with energy and heat, yet it lacked awareness. The laws of physics were hard at work, but there was no consciousness present to record the light or feel the heat of the expansion. After about 380,000 years, the universe cooled enough for light to finally travel through space, leaving a faint glow we call the cosmic microwave background. But after this first flash, the cosmos went dark for millions of years. During these cosmic dark ages, gravity began to pull at microscopic variations in the cooling gas. Across vast distances, matter began to slowly accumulate in the dark. This process was driven by dark matter. While emitting no light, its gravitational influence provided an invisible scaffolding dictating where every galaxy would be built. Hydrogen gas flowed into the intersections of this web, collapsing until the first stars ignited. The universe had created its first structures, massive, glowing galaxies spanning the void. Yet, despite this newfound light, the theater remained empty. There was still no mind capable of seeing what had been built. The stars that lit this early stage, known as Population 3 stars, were the universe's first large-scale manufacturing sites. Deep within their cores, basic hydrogen atoms were crushed together under extreme pressure. This fusion forged the heavier elements necessary for biology: carbon, oxygen, and iron. When these stars reached the end of their lives, they died in supernova explosions. These blasts scattered their forged elements into the surrounding vacuum. This is why your biology is inseparable from the cosmos. The calcium in your bones and the iron in your blood are literally ancient star shrapnel, manufactured in the hearts of suns that died billions of years before you were born. 4.6 billion years ago, in a quiet corner of the Milky Way, a cloud of this recycled stardust collapsed to form our sun and the rocky planet beneath your feet. Life emerged from the oceans to the land, leading to a 160 million year era where massive reptilian predators were the dominant biological force on the planet. That dominance ended 66 million years ago, when an asteroid 10 kilometers wide struck the Earth. The collision triggered a global catastrophe that removed the reptiles and collapsed the existing food chain. This collapse allowed small, adaptable mammals to emerge from the shadows and occupy the niches left behind. Our presence here is the result of that specific cosmic collision. We are not an inevitable outcome of history, but the product of a series of violent, chaotic accidents. Over millions of years, those early mammals developed upright posture, fire, and language. Homo sapiens began to shape their environment rather than simply reacting to it. The defining moment of our species occurred when a curious mind looked at the night sky and asked why the lights were there. That curiosity evolved from tracking seasons for survival to mastering the orbital mechanics required to leave our home planet. When we finally set foot on the lunar surface, the atoms forged in the first stars had returned to the vacuum of space, finally walking on a different world. This is more than a technical milestone. It is the 13.8 billion-year-old universe finally building an eye, a conscious mind, to look back at itself and understand its own origin. Yet, just as we have begun to see the universe, we discovered that it is fading. In 1929, Edwin Hubble discovered that galaxies are moving away from us, and we now know this expansion is actually accelerating. This acceleration is powered by dark energy, a force that is pulling the cosmos apart faster than gravity can hold it together. This leads to the Big Freeze. Trillions of years from now, stars will stop forming. The universe will be populated only by dead stellar remnants and black holes. Theoretical work by Stephen Hawking suggests these black holes will eventually evaporate through Hawking radiation, leaving the universe in absolute, eternal cold. This eventual return to silence gives our current moment its value. In the immense timeline of the cosmos, your life is the fleeting, beautiful instant when the universe finally got to know its own name.